All right, welcome everyone. Today we are doing a speed run of an EVPN VXLAN configuration where I'm going to configure EVPN VXLAN with, make sure the audio is working. All right, welcome. Okay, looks good. Where I configure a topology with EVPN VXLAN without doing any automation, except for the actual setting up of the base environment. I'm using containerlab to do that. So this is the topology right here. So we've got 2 spines, 4 leafs, 2 hosts, and an external router. I'm going to concentrate on just getting a baseline EVP and VXLAN and routing 2 VLANs between host 1 and host 2. And see how quickly I can do it. Again, no automation. Excuse me. So normally, I would never recommend in production doing EVP and VXLAN because manually, because it is a more complicated setup, and it's a good idea to just have the automation to make sure that you cross all the T's and dot all the I's, lest you cross the I's and dot the T's. So we want to make sure we get everything right. And automation is a good way to do that because EVP and VXLAN is a more complicated configuration than our traditional style of networking. So, in this, I'm going to use my nerd topologies. So that's on my GitHub. Let me put that in. I'll put that in the notes later. So I'm going to copy this and git clone. So this, I'm using a VM, and the VM is using what's called the autobox. And the autobox is just a set of instructions I made to build a virtual machine that will run containerlab and then be able to run this topology in containerlab. We're running containerized EOS. So that is already there. We're running under medium. So there's a huge one that's actually got 50 leaves. So I just added that, but I'm using the medium one, and this is what the medium one looks like. And so there's some basic stuff in here. I'm not even going to use any of this for Ansible. So it's all going to be manual configuration, but I do need to start up the lab topology. So here is my lab configuration. And the only real big differences are that, I'm using the management. I'm creating a VRF for management. And then I'm not giving it any IPv6 addresses because typically when I do automation, I don't include IPv6 addresses, and it'll run into a problem where it takes like 7 seconds to time out of the IPv6 address to move to the IPv4 address. So we're not going to worry about that. So we're going to call this Clo Medium, and I think everything is good here. The only thing is I have to change the version because the version I loaded into Docker. So sudo docker image list is this version here. So I'm going to do a change all occurrences 4.34.14 EFT 3. I think I gave it the wrong name in the tag, but that's okay. So let's go ahead and start this topology. So Clo Medium. So sudo containerlab deploy. Oh, I don't have containerlab. I need to install containerlab. That's pretty simple to do. So I'm just going to go to containerlab installation, and then there's just running a quick script. This is Alma Linux based, so Alma 10. Oh, it doesn't like this because this is Alma 10. Am I going to have to... maybe this one. Oh, that was set up. Oh, that I don't have to worry about that. I think this will work. Okay, that works fine. And then I have to run this command right here. Your username, so Tony. Right there, and there we go. Okay. CLab admins. I had it in my instructions down here. This command. There we go. Okay. So we should be able to run this now. Sudo containerlab deploy. There we go. So 5 minutes in, we've got it going on. We've got it configured. So while that's starting up, let's go to PowerPoint and talk about some things. Let's see if I have a... All right, I'll create a new PowerPoint document here. VXLAN speed run. I'll do a copy and paste of a topology here. I have it in another window. I'm going to try to do all this from, I'm going to try to raw dog this, as they say. Excuse me. So I'm not going to use any automation, and I'm not going to use... I'm going to try to do all from memory. I'm probably not going to be able to do everything from memory. We'll see. So we only have 2 spines. And we only have 2 pairs of leaves, so I'll just get rid of those. So this is our topology here, and then I've got 2 hosts. Host 1. And I'll do that as green. It's Kermit the Frog here. Host 2, and then we're going to dual home each host. If I feel really cocky, I'll do the external router too. And then we also have to make some choices on what we're going to do. And I'm feeling ambitious. I'm feeling a little bit cocky. And so what you can tell, I've spent a career in PowerPoint. And what I'm going to do is I'm going to do leaf 1 and 2. So this is leaf 1 and leaf 2. I'm going to do them in an MLAG pair in leaf 3 and leaf 4. I'm going to do EVPN all active. So when we have any kind of EVPN VXLAN fabric, we have to make some choices. First one, well, when we're building a fabric, we do it in 4 steps, and I'm going to do them in all 4 steps. First one is the topology. That's mostly done just by virtue of this is the topology right here. But there's some choices that we have to make in that topology. For example, do we do MLAG or EVPN all active or ESIs? And I'm going to do both. So why don't we have both? So let's do both. From that commercial. So EVPN VXLAN, we're going to do both. So this is that commercial where she goes, why not both? I think it was hard shell tacos and soft shell tacos. So we're going to do both. And then we do the underlay. And then we have to pick a routing protocol. Now, most of the time I do OSPF with unnumbered because it's the simplest. But not far behind is I'm going to do EBGP unnumbered. And we're going to use link local addresses, and RFC 5549, or also known as RFC, so 5549. That's actually the old number. It's 8950, I think. Yeah, so 8950 is the new one. That's what we call it now. So we do the underlay, and then we do the overlay, which will also be EBGP, and then we're going to do the EVPN services. So we're going to do 2 VLANs, 1 VRF. So these are the choices we make: the underlay, the overlay. Also, we're going to do the underlay is going to be head-end replication. Because we're using containerized EOS, we don't have multicast that we can do for the underlay, and also just saves us a bit of time. For smaller installations, it probably doesn't. It's probably just better to do head-end replication because it's the easiest. So we've got all that stuff picked out. So the that means that if we're going to put the first 2 in an MLAG pair, then I do need to configure a port channel between them to act as my MLAG peer link. And I also want to show that you can do both at the same time. I don't really have a preference of one or the other. There are advantages and disadvantages to both. MLAG's been around for a lot longer, so it might be slightly safer. And that's just because, let's do no fill, red outline. Didn't mean to do that. Send it back. Yeah, so it's been around for a lot longer. So it's a little bit more understood. And it's also faster to do its failover, because with ESI you have to withdraw all the ESI routes for the dead leaf, and it can take a little while for that to propagate. But if you have an MLAG failure, it's almost immediate. The advantage to doing EVPN all active or ESIs on leaf 3 and 4 is that I don't have to connect the two together, and you also it's a little bit more flexible in terms of upgrades and hardware, because leaf 1 and leaf 2 have to be within a certain software range. You should be running the same software version, but if you're upgrading, you might have to stagger the upgrades because you can't go too far away in code. Whereas with ESI, it can be anything that supports ESI. It can even be any vendor. Also, leaf 1 and 2 have to be the same hardware model, whereas leaf 3 and 4 do not have to be the same hardware model. So operationally, a little bit more flexible with the all active. Now, there's people that say that it's better to do it because ESI, because it is multi-vendor. I don't really think that we do too many multi-vendor fabrics. I would never do a multi-vendor fabric if I could help it, just because of all the tooling and troubleshooting and stuff. And they claim, some people claim that MLAG is a black box. You don't know what's going on. But I like, what I consider a black box is I don't have any show commands, but I do have show commands for MLAG. So we've been troubleshooting MLAG since like 2008. So I'm totally fine with troubleshooting MLAG versus troubleshooting EVPN all active. In fact, troubleshooting MLAG is probably a little bit easier. So it's kind of a wash which one you go with. I'm fine with either one, so I'm gonna split the difference, and we're just gonna do both here. Hi Tristan, welcome. So what I'm doing, just to bring everyone up to speed, I'm doing a speed run of a manual EVPN VXLAN configuration. So I'm using no automation, and I'm going to configure this this right here. So this is spine 1 and spine 2 with no automation as fast as I can. So I'm 15 minutes in and I'm about to get started. So I'm going to go into leaf 1. This is, by the way, this is on my Autobox, and it's a fresh installation. So everything is fresh, and show version. So it looks like we're good. So that should be 1F instead of 1.4, but that doesn't matter. I'm going to run some baseline configurations on here. For one thing, I'm going to do SSH keygen and build me a private public key pair on my system so that I can SSH in without a password. That's going to save me a little bit of time. Now, here's an interesting thing. It used to be RSA. Now it's using ED25519. I don't really know what that is. So we'll just do that. And then cat SSH ID.pub. ID. It used to be ID RSA pub. Now it's whatever this is. It's shorter, but Arista EOS at least supports it. I don't know how far back it supports it, though. So SSH admin at leaf 1. Config mode, or enable config mode, and then username Tony is role is network admin, privilege is 15, the highest privilege, and then secret I'll do Tony123, and then username Tony, SSH key, and then I just paste this. So theoretically with this, I should be able to log in as Tony without a password, and I can. The other thing I need to do is I need to issue, well, I don't need to do this, but these two commands, and they just drop me right into privilege exec. So it goes right to the, so I don't have to do enable. Again, it just saves me a little bit of time. So if I do show run, and then I take these two lines, and then I paste them here, and what I'll do here is, for the first one will be spine 1. And just paste all of this. And then if I do SSH admin at spine, or SSH Tony at spine 1. All right, so then the next one will be spine 2. I'm going to keep a SSH window into all of them. Config mode. So if you were taking like a level 3 certification exam, this is the kind of stuff I would do if you were doing it all manually. I've done the level 3 certification exam. I've done it, but I've done it so long ago. One, I don't remember it, and two, they've got different versions of it. So I couldn't help you if I wanted to, and I can't, and I don't want to. Because that would be bad, but also I don't remember it. So, but whenever you're taking these kind of exams where you have to like do all this stuff, it takes it's a good idea to take a little bit of time and just get everything sorted so that you're quick, because that's the name of the game, is speed for these kind of things. Level 3 exam, I think you have 4 hours to complete a set of tasks, and you have to do all of them. So admin at leaf 1. All right, that one's already done. And then leaf 2. Leaf 3. So cutting and pasting isn't automation. At least I don't consider it automation. And we really shouldn't be cutting and pasting in 2025. So, but it is a good idea to have the skills to be able to do this manually, so that you know you can do the troubleshooting. Because automation will take care of the configuration, but it won't take care of the troubleshooting, at least not yet. As Admiral Kirk said in Star Trek II, The Wrath of Khan, you have to understand why things work on a starship. Okay, so the spine 2. And so I'll do, I'll do vi.ssh config host user Tony. So host leaf 2. Sorry, that'll be leaf 1. So spend a little bit of time up front. And now I've got access to all these. Okay. So the other thing I need to do is I need to come up with, so topology is all done, and then we need to do the underlay. So I need to do an underlay diagram because I need to specify some things. Specifically, I need to choose loopback addresses for the underlay. I'll do 10, 1, 255, 101. I don't know why spines seem like a 101 and 102 thing to me, but that's the space they occupy in my head. And then for leaf 1, I'll do .1. Leaf 2, I'll do let's do 255 1. Just flip that around. Doesn't really matter. Just be consistent and predictable. .2. And even if you're not doing this on a screencast, it's a good idea to at least write this down, because you'll get really confused pretty easily if you don't do this. And then we need a loopback 1. So loopback 0 is for the EVPN peering, and loopback 1 is for loopback 1 is for the VTEP. And because we're doing MLAG, leaf 1 and 2 will share the same VTEP address, which is interesting. And then because we're doing EVPN all active on leaf 3 and 4, we are not going to share a VTEP address, and they have their own individual ones, which correspond just one octet off on loopback 1. So again, that's kind of being predictable. The other thing is I need to pick some AS numbers, and I'll do what I normally do, 6501 for the spines, and then we'll do 65101 for leaf 1 and 2, and 65103, and then 65104 for our for leaf 3 and 4, because they're not in an MLAG pair. They each need to have their own. So that's what we're going to do. So that's all the information I need for the underlay. Because I'm doing eBGP unnumbered, I don't have to put IP addresses on the leaf and spine configs. So let's go ahead and start configuring this now. So I can do this by interface loopback 0, IP address 10.255.1.101.32. And then I don't put loopback 1 on the spines. So spine 2, config mode, interface loopback 0, IP address 10.255.1.102/32. And the whole purpose of the underlay is to put the loopbacks into a routing table so we can have IP connectivity between loopback and loopback. That's it. That's the only thing the underlay does. If you're getting it to do more than that, you're doing it wrong. And if you're making it any more complicated than that, you're overthinking it. I could use ISIS for the underlay, OSPF for the underlay, BGP, IBGP. We're just doing this one because I'm kind of showing off. I could be overconfident.
You sure about that? You sure about that? You sure about that?
But I think, because I've done this enough.
Actually, it's going to be super easy, barely an inconvenience.
So I did a soundboard to be funny and obnoxious. So 255 to 255.1.2 10.255.1.1 because loopback 1 is shared between leaf 1 and 2, and that's because they're in an MLAG pair. If they're not in an MLAG pair, and if we're doing EVPN all active, then they have their own unique loopback ones. If we were doing EVPN all active, theoretically, we could just use loopback 0 for everything, for the peering and for the VTEPs. But I think it's better to have them separate. Okay, so config mode interface loopback 0, IP address 10.255.1.3, interface loopback 1, 2, they're all unique, and then finally 3. Loopback 0, or interface loopback 0, 251.4, 2.4. All right, so that's done there. And now, now that they've got those addresses, now it's time to configure BGP. So IP routing. IP routing. Because I don't think it's enabled by default. Now we are going to need it. There's a couple of things we need to do for IPv6, but we'll get that when we get to it. I might need to look those up. Don't need that. Okay. And so router BGP 65001, router ID will be 10.255.1.101. Always set a router ID. We're going to do no BGP default IPv4 unicast because we're not going to do IPv4 unicast. We're going to do IPv6 with routing IPv4. Anyway, it's a whole thing. We do need to do BGP. All right, so there's something we need to do in order to do multi-hop. Default multi BGP default. Nope. Might have to look something up already. There's a command that enables ECMP. BGP by default doesn't spread routes across multiple interfaces, but we need that for the underlay. So there's a command. I don't remember what it is. BGP default. No, it's not default BGP. All right, let's look it up. I'm trying to do this as little as possible. So BGP, ECMP, Arista should be in there. I'm going to see it. Maximum paths. All right. So it wasn't even BGP. So it's maximum paths for ECMP 4. All right. So that'll be multi-pathing. I think that's it. So now we do neighbor underlay group, peer group, and then neighbor underlay. Since we're spine, we're going to do next hop. Is it next hop self? And then I can't remember if I need to do that or not. And we're not going to set up remote AS. And I think that's it. We don't need eBGP multi-hop for the underlay. We're not setting the local AS. We're not doing that. think we're okay. Yeah. And then we're going to do neighbor. Oh yeah, I forgot something. So show LDP neighbor, and this is going to be in the config part. So this will be in leafs, and this will be in spines. Because what we need to do for the underlay is for the spines is for leaf 1 through 4. That's Ethernet 3 through 6. So interface Ethernet 3 through 6, IPv6 enable. And we're going to do MTU 1550. I normally would do the MTU to the platform max, but this is a containerized version, and I don't think it handles 9,000 byte MTUs. So we would normally do like 9216, but we're just going to do 1550. The host can do 1500 byte MTUs, and the 50 bytes on top of that will give us all the headroom we need to set, because VXLAN is a 50 byte header. They'll give us all the headroom we need. So that's what we need there. And then on the leafs, interface 3 and 4, MTU 1550, no switch port, IPv6 enable. I don't think the order of operation matters that much, usually. Okay, so just paste that, and then here, for the leafs, paste that here. Oh, interface E3, 4. Because the nice thing about RFC 8950, or what we used to call 5549, is that I don't have to put IP addresses on them. It uses link local addresses. So if we do show IPv6 interface brief, we can see that I've got on my leaf 3 and 4 go up to spine 1 and 2, and there's link local addresses on there. So that's just what we're going to use. Okay, now back to router BGP. And then it's neighbor Ethernet interface, Ethernet 3 through 6, peer group underlay, and neighbor interface Ethernet 3, peer group underlay, remote AS 65101. And then 5 is 103. So instead of saying the neighbor's IP address, we're just saying the neighbor's we're just saying the neighbor's interface, and then it will detect the other side through neighbor discovery, which is pretty cool. So like if I do show IPv6 neighbors, show IPv6 ND, neighbors. I should be able to detect them. Anyway, we'll do that in a second here. Oh, I need to do IPv6 routing. Yeah, that's something else I can't ever remember. There's 2 commands. That we need to do. IPv6, yeah, so these 2 commands. So IPv6 routing. Let's go ahead and put it into the pile here. So it's IPv6 unicast routing. And then IP routing IPv6 interfaces. So I'll just paste this into each one of these. And then router BGP, IPv4 address family, IPv4, neighbor underlay activate, neighbor underlay activate, underlay, neighbor underlay. Also command here. It's not default originate. Select, BGP next hop address family IPv6. I think that's what it is from over here. All right, so show IPv6 neighbors. All right, so there we go. Now we've activated the interface. We've done neighbor discovery. So now we know what the neighbors are. So show run. I don't even need to do an address family IPv6. So that should be good there. So I'm just going to copy and paste this. And I'm going to do this into the spine. So router BGP 65001, router ID 10.255.1.102. And then I think these are the same. Yeah. All right. So, and then over here, router BGP 65101. No BGP default IPv4 unicast. Maximum pass for ECMP4. Get rid of this now. Neighbor underlay peer group. Neighbor underlay remote AS 6501. Neighbor interface E344 peer group underlay remote AS 65. Oh, I don't need to do that one. And then address family IPv4. BGP next hop. Address family IPv6. Neighbor underlay activate. Show BGP summary. All right, we're done. All right, so if I do, oh yeah, the other thing I need to do is address family. I'm in address family. So network 10.1.255.101. 10.255.1.101. Network 10.255.1.102. So if I do show IP route, I'm not getting any routes. Should be announcing them. So there's another command I'm not doing that sounds vaguely familiar. So IPv6 unnumbered Arista. Might find my own posts in here. Yeah, this is me. Here's IPv6 unicast routing. Yeah, there it is. Neighbor. That's it. That's the command I'm missing. So that was from Ivan Pepleniak. I've met that man. He's a really nice guy. Slovenian. So now, all right, that didn't work. So get rid of that. Oh, yeah, so duh. It's a problem with cutting and pasting. Neighbor, underlay, next hop, address family, IPv6 originate. There, that should do it, and we should have routes. There it is. That's the route we're looking for. So I just need to do reciprocals of this. So this is slightly more complicated. It would take slightly longer for me to do it with IPv6 as the underlay because I don't have all these commands memorized. So neighbor, underlay, next hop, address family, IPv6, originate. Okay, we're established with leaf 1 and we're advertising 1 prefix. So I should see 2 routes. There we go. Let's get those routes going back and forth. So neighbor, underlay, next hop, address family IPv6, originate. So we're just originating the next hop with an IPv6 address. That's all we're saying. Show IP BGP summary. We're advertising a prefix. Now if I do show IP route, I do ping 10.255.1.101 source 10.255 1.1. Let's see if I got a route in there. I don't. Oh, I didn't put it in there. So network 10.255.1.1. So now it should work. There we go. We got the route. All right, we can ping. We got a winning formula here. So router BGP 65.101 because we're sharing it. Router ID, but the router ID is going to be unique. 10.255.1.2, and then I'll just copy and paste this. And then, oh yeah, pasted the wrong part. So this is what goes into the leaves because there is no 5 and 6 interface 5 and 6. This is why automation's good, because you don't make these silly cut and paste errors. Originate network 10.1 10.255 1 2 yeah 1.1 and 2.1. Oh, so no, it's 1.2. Yeah, we don't share the that one. We share 2.1 should be the same on both. Yeah, 2.1. So 1.1 and 1.2. And then 2.1 and 2.1. All right, so that looks good. So we do show IP BGP summary. We're advertising 2 prefixes. We've got to show IP route. I've got the spines. I'll do ping 10.255.1.101. Source 10.255.1.2. Okay, that works. So router BGP 65.103. Make sure I got the, yeah. Router ID 10.255.1.3. Address family IPv4, neighbor underlay activate, neighbor underlay next hop, address family IPv6 originate, network 10.255.1.3.2.3. We're advertising 6 prefixes. Why are we advertising 6? That's very suspicious. Oh, probably because it's all looping around. That's all right. All right, router BGP 65.104. Neighbor underlay activate, neighbor underlay next hop, address family IPv6 originate, network 10.255, 1.4, 2.4. Let's write these in case stuff goes down. All right, so if I do show IP BGP summary, three and 4, I'm getting, why am I only getting one receive route from this? Show run. So 1.1 and 1.2, 3 and 4. Okay, that's good. 2.1. I should be getting 2.1 from 2 places. I should have 2 routes in here. It should be Ethernet 3 and 4. 2.3 should be 5 and 6. That's normal because they're only coming from one place because it's just one VTEP. So show IP route 10.255 2.1 detail. Show IP BGP route. Did I maybe not advertise it right on leaf 2? Oh, because I gave him the wrong loopback address. That's why. It's a good thing I checked. Yeah, now I'm getting from 2 routes. That looks more bueno. That kind of bothers me, though. Why is there 7 routes going to 3 and 4? Why is there 7 routes going to leave 2? One dot one and 2.1. 1.1 and 2.1. Show IP route. Show run. 1.2 and 2.1. That's confusing. But show IP interface brief. 1.2, 2.1. 1.2, 2.1. Still getting more from there. Oh, you know what? Is because I did next hop self. Should I have done next hop self? I think so. Because show IP route. All right, we'll just leave it that way. See if anything comes up. All right, so the underlay is done. So now we can move on to the overlay. And not much has changed. With the overlay, all we're doing is peering. Between loopback 0 and loopback 0. We're doing a BGP neighbor on a different address family. So we're not, for BGP is not using the IPv4 address family. So, so in spine 1, we'll do router exit out of here. We'll do address neighbor EVPN peer group. EVPN source. We have to specify a source. Update source is loopback 0. We also have to do eBGP multi-hop, because going from loopback to loopback involves multiple hops. The TTL is set to 1. That'll cause a problem. Packets won't make it there unless we set that command. Neighbor EVPN What else do we need? We need send community. Extended. We don't normally say extended. We don't actually have to say extended. Maybe we're back and get some tea. All right, neighbor extended, and then neighbor 10.255.1. That one peer group EVPN, and then remote AS 65.101. Two, 3 is 3, and 4 is 4. And the neighbor EVPN peer neighbor 10.255.1.1 is peer group EVPN. So share all those attributes. An address family EVPN. And activate neighbor EVPN activate. All right, we'll go to leaf 1. Make sure these match. So neighbor EVPN peer group, EVPN peer group. Let's see if I can do some copy and paste here. So this would be neighbor 10.255.1 peer group. I could probably just do EVPN remote AS 65,001. Yeah, I think I could do that. So go into here and paste. All right, we're established. That was easy. So I'm going to basically just paste that into here and here and here. So the only thing I need to do here is copy and paste this. So paste this. Paste this stuff. Address family EVPN neighbor EVPN activate. And we're established. That's the overlay. We're done. So I'm just about to hit the hour mark. And even with all the explanations, we've got the topology done. We've got the underlay done. We've got the overlay done. Now we get the EVPN services done. I did skip one part. I did not configure one part of the topology. I didn't configure mlag. So I'm going to go back and do that. And in order to do that, that's on leaf 1 and 2. So that'll be interface E1 and 2. And that'll be switch channel. Actually, take a step back. We're going to do VLAN 4094. Put that in the VLAN database. And then we'll do interface VLAN 4094. We need a pure VLAN and an L3 interface on the interface VLAN. And we can use any VLAN you want. I typically use the highest VLAN you have available to you. That's going to be 4094. And then on leaf 2, we'll do the same thing. We'll try to keep them in sync. That way I don't forget something. So VLAN 4094. Then I'll do interface VLAN 4094. No auto state. IP address 10.253.0.1/30. Interface VLAN 4094. No auto state. IP address 10.253.0.2/30. Is that what I did? And then interface. Oh yeah, no. Generally you do this, which is kind of weird, is no spanning tree VLAN ID 4094. You don't normally turn spanning tree off, but we're doing that here. No spanning tree VLAN ID 4094. All right, and then interface E1 and 2, channel group 2000 mode active. Interface E1 and 2, channel group 2000 mode active. So that's this port channel right here. So I gave it the ID of 2000. You have to pick one. I picked 2000. That's the highest one you can normally use, I think. Unlikely to be needed for anything else. And then interface port channel 2000, switch port mode trunk, switch port trunk allowed VLAN 4094. That's the only VLAN we actually have to allow, at least right now. We might have to add another one in a minute. So interface port channel 2000, switch port mode trunk allowed VLAN 4094. Show VLAN port 2000. Show VLAN. So if you're setting this up, we're verifying step by step. So every time we make a config change, configure some aspect, then we're doing verifications as much as we can. All right, so VLAN 4094. Then we configure mlag. So mlag configuration. Domain ID. In a VPC with Cisco, the domain ID is an integer and it has to be unique across your fabric. In Arista, it does not have to be unique. In fact, we're just going to call it mlag everywhere. If we had 100 leaves, the domain ID would be mlag. Why do we have a domain ID? I don't know. The reason why I have it in Cisco is because a lot of stuff is derived from that domain ID, such as the shared MAC address. Because when you put two switches in a VPC or an MLAG, they present as a single switch. They have one system ID for LECP and then one bridge ID for spanning tree. Because even though we disabled spanning tree on one VLAN, it's still going to be active on the others. And in an MLAG pair, they're going to share the same spanning tree bridge ID. And that's derived from the domain ID in VPC on Cisco. On Arista, it's actually derived from the primary's system MAC address. I'll show you that in a second here. So we'll just go down the list. Domain ID, we're not going to do dual primary, anything like that. So our local interface is port channel 2000. Our VLAN 4094. Peer address is 10.253.0.1. Peer link is port channel 2000. I think that's enough. So just copy and paste that over here. Peer address is 10.253.0.2. And the rest I can paste. Peer link 2000. Show mlag. In negotiation. Consistent. So it looks good. We'll also do show mlag config sanity, just to make sure that everything looks right between them. So that looks good. So they're now in an mlag peer. The only other thing I need to do is I actually need a peer between for BGP. So I'm going to do another interface VLAN, so I can carry over that port channel between them. But I'm going to do IPv6. So interface. So let's do VLAN 4093. And then interface VLAN 4093. No auto state. IPv6 enable. That way we don't have to put an IP address on them. So VLAN 4093. Interface VLAN 4093. IP address. Oh no, no auto state, IPv6 enable, show VLAN. Oh yeah, we need to do interface port channel 2000. Yeah, so switch port, trunk, allowed, VLAN, add, 4093. Remember that? We got to do the add thing. Remember how that's always screwed things up?
You sure about that? You sure about that? You sure about that?
Switch port, trunk, allowed, just paste it. All right, show VLAN. All right, so now so router BGP. This might be a reason to do just EVPN all active here. It's a more complicated BGP config. All right, so we're going to do neighbor underlay, do neighbor mlag peer group. Remote AS is going to be 65.101. It's IBGP. And then neighbor interface port channel 2000. Can I do this? Interface VLAN 4093. Don't remember how I did this. Peer group mlag. Address family IPv4. Neighbor mlag peer activate. Neighbor mlag peer. Next hop, address family IPv6 originate. Don't know if this will work. I think this is what I did before. It's getting really kind of complicated, which is why automation is good for this. So show BGP summary. So we have our underlay. So MLAG peer group remote AS 65101. MLAG peer. There we go. All right, it's in there now. All right, so it just took a second. So now we've got everything we need for the underlay. So that's complete. Now we can do the EVPN services. And for the services, we're going to do 2 VLANs. So this is the physical model. And what we're going to do VLAN 10 with a gateway of 10, 1, 100, 1 there. And VLAN 20, let's do VLAN 100. I always do VLAN 10, 20. 200, so host 1, be 10, 1, 111. Host 2, 10, 1, 100, 200.12. So those will be those 2 IP addresses. So we got to do this. And then for the logical, so EVPN services logical model, we've got a couple of things we need to do. First of all, since we're doing, this will be symmetric IRB, which is the default in Arista. There's not really any reason not to do symmetric IRB anymore. Not that there ever were, to do something else. So we needed L3 VNI. I'll use 1,000. Actually use 10,000. And we'll give it a VRF of blue. We'll call it blue. Well, let's do this. I'll do Picard. And then I need a L2 VNI. And this will be on VLAN 10. And then another one will be on VLAN 20, or VLAN 100 and VLAN 200. And so both switches will need VLAN, will need this VRF. All switches will need the VRF. Because in symmetric IRB, whatever you have for an L3 VNI, this will be under VRF Picard. This VRF needs to be on every leaf. So let's go ahead and put that on there. IP VRF, or sorry, VRF instance Picard. VRF instance Picard. Show BGP. In summary, we're established. Good. Instance Picard. It is case sensitive, but the VRF names actually are locally significant, but we treat them like they're globally significant. Then we need to create the VLANs. VLAN 100, VLAN 200. So on leaf 1, be VLAN 100. Just put it in the database. That's all we need to do. And then over here, same thing. We just need to put it into the database. VLAN 200. So we have a checklist. So VLAN is number 1. Then we need, we also need an Anycast gateway. Mac. So we'll do 02, show system, show version. So whatever our system MAC address is, so this 001 Charlie 73. 1 Charlie 73. So 0 1 Charlie 73 000099. Now the reason why I replaced the first octet of 00 with 02 is 02 is known as it is a locally administered MAC address. If you're going to manually assign a MAC address, you want to make sure that you don't accidentally ever collide with another MAC address that might be burnt into a physical chip. 02 as your first octet means it will never be burnt into a chip. That's the locally administered MAC range. So we'll just do just to keep it simple, we'll just do all zeros except for the last octet, which will be 99. You can make it anything you want, but I recommend the first octet, the first 2 digits, be 02. And then we need to configure that everywhere, or actually all the leafs rather. So it's IP virtual router MAC address, and then that. So I just do that on each leaf. So that'll be our Anycast gateway MAC address. So when the hosts ARP for their gateway, that's the address they're going to see. That's the MAC address. So VLAN, interface VLAN. Anycast, we need the VRF. Just do a little checklist here. VLAN, interface VLAN. So most of this I'm doing from memory. I'm actually pretty impressed with myself. How much I'm remembering. Interface VLAN 100, IP address virtual 10.1.100.1. And that means since it's IP address virtual, it's going to use this. So this is our you know what? I forgot to put it in VRF Picard. It's going to, so I have to do the address again. So here it'll be interface VLAN 100 VRF Picard. If you do the IP address and then the VRF, it pulls the IP address off because it figures you're moving VRFs and we don't want to have a collision. So IP address virtual 10.1.100.1. Interface VLAN 200 VRF Picard, IP address virtual 10.1.200.1, and leaf 3 is interface VLAN 200 IP VRF Picard, IP address virtual 10.1.200.1. So then we need the VXLAN data plane. So that's interface VXLAN. And that's done in interface VXLAN 1. VXLAN source is going to be loopback 1, and then VXLAN VRF Picard is VNI 10,000. VXLAN VLAN 100 is VNI 10.100. Show run interface VXLAN 1. So I can just copy and paste this. So what this does is it creates a L3 VNI, which we need for symmetric IRB, with a VNI of 1,000 or 10,000. And then it also creates a VNI of 10,100 and attaches it locally to VLAN 100. These are locally significant VLAN IDs. The VNIs are globally significant. So we're going to do, I'm going to copy this. And it's going to be the same for leaf 2. And then for leaf 3, so VXLAN source loopback 1, VXLAN VRF Picard VNI 10,000, VXLAN VLAN 200 VNI 10,200. because we're doing symmetric RB, not every VNI needs to be on every leaf, but the L3 VNIs do. Okay. And then, so that's the data plane. Now we need to do the control plane, and that's in BGP. So router BGP, whatever. So we're going to do VLAN, or so first we'll do VRF Picard. Did I not do IP routing? Guess I didn't. Oh, I did do IP routing. VRF Picard. IP routing VRF Picard. IP routing VRF Picard. All right, so done there. So what else do we need? Okay, so IP routing, so VRF, so router, whatever. We don't need to do any of these on the spines because the spines don't care. They don't terminate VXLAN. They don't have any VLANs on them other than what they might need for management. In our case, we don't need any. So it's just on the leaves. So VRF Picard. We need to create a route distinguisher. A route distinguisher and a route target. The formatting of them, the numbers are the same, but they serve very different purposes. The route distinguisher needs to be unique across every leaf. So that's why we typically give it the, even in an MLAG pair, that's why we typically give it, we put the loopback 1 address encoded into the RD. So show IP interface brief, just make sure that's the one. Yeah. And then we need to do a route target. Import EVPN 10,000. I just use the whatever the VNI is, and then export, and then redistribute connected. And then we'll do VLAN 100, RD auto, route target. The route target needs to be the same for every VNI. So route target for both is going to be 10,100, 10,100, or you can just do the VLAN ID. However you want to do it, and then redistribute learned. Because what happens now is a MAC address gets learned on a VLAN. That's going to trigger a type 2 route. So that MAC address gets encapsulated, or that MAC address gets put into a BGP route with a route target of 100 on it. And then over here on leaf 3, we have VLAN, well, we don't actually have VLAN 100 on leaf 3, but on leaf 2, so VLAN, any other device that has VLAN 100 on it will be RD auto, and then route target for both is 100, 100, redistribute learned. So they need to match. Then over here I do VRF Picard, RD 10, 255, 1.2, 10,000, route target, import EVPN 10,000, 10,000. So when we learn a route, we add the tag of 10,000, 10,000 for an L3 VNI. We distribute it. The spines are responsible for propagating. So whether it's IBGP or EBGP, the spines act as route servers or route reflectors. Okay, and then just a little bit more. So VLAN 200, RD auto, route target is going to be for both. 200, 200, redistribute learned. So this is the data plane that we're doing for this. I just copy and paste this into leaf 4. And then for VRF Picard, can't copy and paste this one because, or at least part of it. So RD, there's no RD auto, so RD1 255. There is RD EVPN. I don't know what that does. Should probably figure that out at some point. So route distinguisher 10 255 1.3 10,000. Route target. Import EVPN 10,000 10,000. Export. And then redistribute learned or connected. VRF Picard. This is the VRF Picard and BGP. 10 255 14. And then that should be it. The only other thing I need to do now is configure the connected ports. So a port channel here and a port channel here. Now there's two different approaches to them. One is MLAG, so that's one strategy. So show LDP neighbors. My host is connected on Ethernet 10. Actually, let's go ahead and configure the host. SSH admin at host 1. Channel group 1 mode active. Interface port channel 1. No switch port. IP address 10.1.100. 11 IP route 10.1.101. So host 1 is configured. It's not really a host, of course. It's just another switch pretending to be a host. I could have actually put a real host in here, but this is easier. We're using LECP. Anytime you do a port channel, best practice is to use LECP. That's mode active. You don't have to use it. It doesn't actually make it any faster. The only thing that LECP does, and this is something the people don't even realize, it's what they say on all the bro podcasts. You don't even realize. What people don't seem to realize is that the only thing that LECP does, the only thing, is if you have a configured lag, port channel, lag, same thing, it determines which members of that lag are going to be active in that lag. And it does this, it evaluates this by looking at to make sure that the system ID is the same on all the ports. Because if the system ID that's reporting on the different ports are different, that means you're plugged into the wrong device. So really, LECP, all it does is it's like a miscabling protocol. LECP does not load balance any packets. Link aggregation does. But LECP by itself, its only purpose is to evaluate the links configured in the lag and determine if they're going to be part of the lag. So, we actually have a four-way lag. Let's go ahead and do the four-way lag. So we'll put Ethernet 1 through 4. So if I do show LAB neighbors, Ethernet 1 through 4 is plugged into 3 and 4, 3 and 4. All right, so that's configured. Interface port channel 1, no switch port, IP address 10.1.200, 12 IP route. This is why I put the management interface at its own VRF. And I'm going to add 3 and 4. Interface 3 and 4, channel group 1 mode active. So none of the interfaces are up on the port channel because the other side isn't sending LECP PDUs because they don't have LECP enabled. So we're not getting any PDUs, and so we're not getting any system IDs. So they are not part of the lag, so they're not up. That's what we want. Because if we don't use LECP, if you have a link light, it's part of the lag. That's all that takes. It's a very low bar. LECP is kind of like the bouncer that makes sure that only the cool links come in. Yeah, so we're not getting any there. So we're going to fix that. So interface 10 and 11, interface E10 and 11. We're going to do channel group, let's do 10 mode active, interface port channel 10, and we'll do switch port mode access, switch port access VLAN 100, MLAG 10. So that should be enough right now so that host 1 sees some LACP system ID. So we do. So we see 4 link lights, but only 2 of them are giving us system IDs, and they match. They're all matchy-matchy. So if they matchy-matchy, then they're part of the lag. The other 2 are not sending any PDUs. So we'll do that. We'll configure leaf 2. Now watch this. We're going to do interface E10 through 11. Channel group 10 mode active. So now we're sending LACP PDUs. Interface port channel 10. Switch port mode access, switch port access, VLAN 100. Now watch this. We're getting 2 different sets of system IDs. So to fix this, we'll do MLAG 10. So MLAG 10 matches on both sides. So now they all match. So now we have interface port channel 10, and port channel 1 on this side. All 4 links are a member of that port channel. So now if I ping 10.1, 10.1, 101, it takes a second to ARP, and if I do show ARP, so that's that virtual MAC address. So that's working exactly as we'd hoped. I like it when that happens. And so on host 2, it's going to be different. It's going to be a different story because we're not going to use MLAG. We're going to use EVPN all active, which is part of the EVPN standard. So we'll do interface E10 through 11. We'll also do channel group 10. It's locally significant. It doesn't have to. It doesn't matter if it conflicts with something else. We'll also do LACP. Now, and then we do EVPN, Ethernet segment. And there's a couple things we need to do. Oh yeah, we need interface port channel 10, Ethernet segment. And then we need an identifier, which needs to start out with 00. I think we can do, yeah, we'll do auto. And we'll derive it from LACP. And then we'll do system, LACP system ID. We do need to give it a system ID. So we'll do 000, 000, 2 for host 2. So we're going to copy this. So the other side is interface E10 through 11. Channel group 10 mode active, interface port channel 10, EVPN Ethernet segment, identifier auto LACP, and then LACP system ID is 000, 000, 002. It needs a match on all ports. So for example, there we go. So I just did all zeros and now we get 2. So now they're all bundled. And if I ping my default gateway, it takes a second to ARP. Sometimes it takes a few seconds to ARP. Unless I got something misconfigured. All right. So if I do show interface port channel 1, let's do some troubleshooting. What I'm going to do is I'm going to look for this MAC address. Actually, you know what? Let's do this. Interface port channel 1, router MAC, MAC, MAC address, router. So I'll just set the MAC address as that, so it's easier to spot. What we're looking for is show MAC address table, VLAN 200. All right, we don't see it in there. Oh yeah, that's right, because I didn't configure the ports for VLAN 200. That's why. Duh. If we do show VLAN, it's not on the port. So interface port channel 10, switch port mode, access switch port access VLAN 200. Switch port mode access switch port access VLAN 200. Now I should be able to ping. Still don't see it. Show VLAN. See it on port channel 10. Port channel 10. We just see our local gateway there. All right, there it is. So sometimes it just takes a little while in this virtual environment to ARP. So there it is. Now I should be able to ping the other address. So 100.11. There we go. 96 minutes. That's all it took. So I just did a speed run of EVPN VXLAN config with BGP outnumbered as the underlay and BGP as the overlay. I did both MLAG and EVPN all active, and that's it. So that was a speed run of this config. So what I think I'll do now, so we're complete. What I think I'll do now is I will, under Ansible, I can do a backup of the configs, and then I'll post it onto a, I'll put it in the, I'll put it into the notes of the episode, or of the video notes. So I will, so I have an inventory. Yep, so that should do it. So I'll do, so backup configs. Hosts, we'll do fabric. That should be the spines and the leaves. And tasks. And that will be Arista EOS config. I think that's what it is. Direct backup options directory path. Backup option. I think that's enough. And we'll do backup configs. And there we go. So I'll put that on GitHub somewhere. It'll be in the notes of the video. All right, so that's it. I hope you enjoyed watching. Or thank you. I know some of you watched, some of you didn't. That's okay. But that'll do it for today.